Grüezi YouTubers, here is the guy with a Swiss accent, with a new episode around sensors and microcontrollers.
A new mailbag.
Let's first start with the things I already unpackaged, like this one here. These are several small boxes with wires. Here you have the standard colors and here you have the special colors. So let's have a look inside. Very simple design, just all the colors. I think everything is 2, 4, 5 times 10 meters, 50 meters, stranded wires. It's a 22 AWG and it's not very flexible here, but it's a perfect wire for my projects and I like the selection of the different colors. I keep it together like that, and these are the same 22 AWG and this is 20 and this is 28 AWG, also stranded wires, but silicone, very flexible. Only the special colors, I did not buy the standard colors. But together like that on a shelf, it's really a perfect thing. I have all the colors handy. I can tear it out and cut it here to the length I need. Just sitting like that on a shelf on the opposite side of my lab. The next one is also unpackaged, or at least partially. It is a USB charger from BlitzWolf and it is Qualcomm Quick Charge 3.0 enabled. I bought this one not because I do not have any USB chargers, but because I do not have one which does a QC3. Now what is the difference between a normal charger and a QC30 charger? QC0 from Qualcomm adapts the charging voltage to the needs of the smartphone, so it should be able to charge much faster. Normal smartphones charge at 5 volt and the QC3 go up to 12 volt, so with the same current they can charge more than 2 times faster. This particular device can charge with 12 volt and 1.5 ampere, and this is 18 watt, which is quite a lot compared to the normal 2 ampere and 5 volt, which is 10 watt. So this should charge faster. Now my iPhone currently cannot use this, but I just want to understand how this standard works. That's why I bought this one. I will also link a small video from Banggood where they show you the details of this product. The next one is very similar in size and also the make of the packaging, but the content is quite different. It is transparent and it is a USB disk drive case with a adapter for USB and the cable is here. So we can connect like that and you see it's USB 3. Now why did I buy something like that? As you know, I'm playing around with Raspberries. I did some performance tests with SD cards and many viewers suggested not to use SD cards because of the wear and tear, and this is why I want to check out to use a normal USB drive. Now the Raspberry does not need 2 big drives, and this is why I bought this one. I think I can salvage a few disks from all laptops or so, which are usually only maybe 500 gigabyte or 200, even 250 gigabyte, which is enough for any Raspberry project. And this is how I can save money. Now here I have another opportunity. I have a relatively small, this was my first solid state disk, SSD disk. It has only 240 gigabyte memory size, and this is not sufficient for my work today for a C drive, because I have many more programs installed. So maybe this is the first candidate which will be mounted in here. ORICO is a brand I trust. I have many different things from ORICO, and I think they are a premium brand, at least in my view, and I never had problems with their products. Now the next in this series should be this one here. This is nothing interesting here, but here I see something. It's also from Banggood, and this is a cable. So let's unpackage. This is a special cable which might be necessary for the Raspberry Pi. It has a SATA connector on this side, and it has USB on this side, but it has two USB connectors. So why the hell is this? Do I think it is faster to have two USB connectors instead of one? No, not at all. But this one is to plug into the Raspberry Pi, and this one is to connect into a dedicated USB charger, because the Raspberry Pi is usually not able to supply the complete current which is necessary for a mechanical USB drive. I will do some tests with it, and so I have the two possibilities, the one without an additional plug and the one with additional plug. And maybe I even have to create such a cable with two USB plugs for this case here. We will see. What else was in this package? It is a ESP32, a second one with this OLED display here, and I like this concept because I have many projects where I want to have an OLED, and to have it on the same board I think will save me some hassle. And the next, which was also in, was just normal connectors. I use them quite often to connect PCBs with relatively thick wires. Nice color. Usually they are green. The next ones I unpackaged already are these battery holders. They are for LiPo cells, and they are quite special. I used these LiPo cell holders till I did my experiments with solar energy. Their wires are quite thin, but this is not the real problem. The real problem is here. This spring here is also very thin, and what happened is, if you have maybe 2 ampere or so, it starts to heat up and it starts to stink, and afterwards this spring does not work anymore because it was overheated and it lost all the tension. So you can throw it away. This is not the way to go if you want to do experiments with higher currents. This is okay if you want to connect an ESP or something with a few milliamperes, but for sure not for amperes. This is why I bought this one. It has two differences. One difference is it has here strong connectors, and the second one is it has also, the connection is also quite thick. And what I did is I just soldered quite thick, I think it's AWG16 wires to this holder here, and now I can go with 5 ampere or something without any heat, and also I do not lose a lot of voltage across the connector and across the wire. This is a much better thing, and also it is possible to solder them on a PCB like that. I do not recommend to buy these, much better quality here. The next one is also unpackaged, and it consists of 2 different parts. One is a sensor, obviously, with some connectors, and the other one is a IC, integrated circuit, and it's a MAX6675. So what do these two do? They consist of the MAX 6675. It's a K-type thermocouple to digital converter, and it is SPI compatible. It has 12-bit and can be connected with clock and serial output. It has no serial input or no MOSI, because you do not write in this direction. It's just read only towards the microcontroller. And this one is a K-type thermocouple. I will replace these thermocouples with this one. Now you can imagine why. I use it in my oven for reflow soldering, and there I go to more than 200 degrees, and this heat shrink tube is not really very sophisticated, and also here the contact is not is quite small, the area where we measure, and also this material here is really not for high temperature. This one is all metal, much better. Now, what is a K-type thermocouple? We have basically 2 similar types, the K-type and the J-type. The K-type goes to 2300 Fahrenheit or to 1260, which is anyway way too high for me. And the J-type would only go to 760 Celsius or 1400 Fahrenheit, which is okay for me. The rest is very similar. Most of the thermocouples you find are on AliExpress or on Banggood are K-type. So they fit perfectly with a MAX 6675. So with these 2 parts I should get a very accurate and very cheap sensor for my oven, and also for other situations. Maybe I will also measure the temperature of the solar panels somehow. But this is probably not easy because they are usually plastic and not metal. Now we start with the real unpackaging. Here we get something I thought is interesting. It is a Mega 2560, which is a normal Arduino name here, but it is Pro. So let's open it. Well packaged. A huge chip here. This is an Atmega 2560 with many pins, and all the pins are here, and a serial to USB, a voltage regulator, even 2 voltage regulators. I have to check what this means, but nevertheless it is the replacement for this board. And you see here you have lots of space, and they just omitted the space. They omitted also the power jack. It has only a micro USB, which is standard these days, no problem. But it has a reset switch, it has a resonator, So the rest seems to be quite similar, and even an ICSP connector here if you want to upload something directly to the chip. And the rest of the pins seem to be the same as on this board. I just have to find out why it has two different voltage regulators, two AMS1117. So the solution is quite simple. This is a 5 volt and a 3.3 volt regulator. Nothing special. If you want to buy one of these, you have also to order these pin headers here, the 2-row pin headers, because they do not come with it. Like that, and then you can cut them to length, and also here. The next one is a huge package. Nothing. Here is something, and here is another one. Let's check what it is. It is a huge switch. It has just on and off, and it is 12 volt and 20 ampere. So this is something really for a quite a strong solar panel, for example, but I liked also the huge size of it, and it has an LED built in here. So I connected it now to 3 volt, around 3 volt on my bench power supply, and you see here I can switch it on and off. Very neat. It's quite hard, so it's really not for a small case. It has to be something really heavy, because otherwise you cannot switch it easily. It's not a light switch, it's really a heavy switch here. Another one I already unpackaged and named. This is an SI2301 P-Channel transistors, SMD. I think there are 100 pieces for $1 or so. Very cheap. If you look at the data sheet, we see that we can use it up to 20 volt, which is in most cases in our project sufficient. But what is very important is the on voltage. It's where this transistor switches on, and it should switch on before 3.3 volt, and we have here at 2.5 volt or minus 2.5, because it's a P-channel, we can switch 3 ampere at 4.5 volt. For the 5 volt logic we could even switch 6 ampere, which is anyway quite a lot. I do not use these small chips for power applications, but for small 100 milliampere, 200 milliampere, something like that, to switch a sensor on and off and stuff like that. These are perfect transistors. I think you should have a few of them somewhere in your drawers. Next one has an interesting detail here. Numberings. And if we look on this side, it says Wi-Fi kit 32. What the hell is this? So let's have a look inside. An interesting board here with an ESP32 flash. I assume this is the USB to serial connector, and on this side we have an OLED display. So it is similar to this one, where we have the OLED display on the same side, and the board is a little bit bigger, and this one is quite small, and we have the chip on the other side. But we do not have a shielded ESP, we have an open ESP. I think it has no certification at all. This is a battery connector for a 3.7 volt lithium battery. So this is quite a small device for I don't know what project. This one, however, is not cheap. It is a little bit more expensive than this one, but it has also this battery connection. And here we have something very interesting. From what I saw, this is to be sticked on these pins, because actually then you can see from the side which pin it is, because it has only silk screen on the bottom, and if you put it like that on your PCB, then you do not know which pins are which, so they suggest to have this trick here. I'm not sure if this will work, but at least we can try it. Now this is one of the bigger ones of today. Banana plugs, but this time not male, but female types. I recently ordered 48, I think, male banana plugs, and now I wanted to have some female plugs, and let's see how they work. They are for soldering, and the quality seems to be okay. I don't press them completely in, because then it's really hard to get it out. It's quite a tight seat here. And here I have one which is also open, and it contains this small board. Actually, I ordered 2 of them, and this is the unpackaged one. It is a small OLED display, and if we compare it with the normal OLED display, the 0.96 inch OLED display, we see that it has the same width, but only about half of the height. So for small status indicators, this is a nice addition to my OLED displays. And if we compare the 0.96 inch version to the 1.3 inch version, and this one here, we have all the different possibilities to choose from for our project. So this is today's mailbag, and this is a selection of the parts I presented today. I hope 1 or 2 parts were interesting for you, and or maybe one or the other information. I hope this video was useful, or at least interesting for you. Bye!